Good evening everyone. My name is Kalyan Kumar Reddy. I am from VC Department of VA section. Today I am talk about extension tables for sequential logic gates. Extension tables for sequential logic gates. This is extension tables. Extension tables are essential tools in sequential logic gates used to determine inputs condition in for flip-flops. They help in designing flip-flop input signals to achieve desired state transition. Understanding extension tables simplifies the process of designing and analyzing sequential circuits. Sequential logic overview. Sequential logic circuits depend on both current input and past states. Flip-flops are fundamental building blocks in sequential logic for storing state information. Designing sequential circuits involves determining the appropriate flip-flop inputs to transition between states. What are the extension tables? Extension tables specify the required flip-flop inputs for desired state changes. They complement characteristics tables by forcing on input conditions needed for transitions. Extension tables are used to find manual input signals for flip-flops to achieve specific state transition. Difference between characteristics and extension tables. Characteristics tables describe the next state based on current state and input. Extension tables indicate the next input required to move from the current state to next state. Both are used together to design specific initial circuits. Types of flip-flops covered. Extension tables are primarily used in flip-flops like SR, JK, D, and T. Each flip-flop type has unique extension requirement for state transition. Understanding this difference is curricular for current circuit design. JK flip-flop extension table. The JK flip-flop extension table shows input needed for all possible states transition. For JK flip-flop, the inputs J and K depends on the current and next states. It is variable because it can perform as an SRT or D flip-flop with operand inputs. D flip-flop extension tables. The D flip-flop as straightforward extension table since its next state depends only on the D input. The table indicates that to achieve a desired next state, D should be set equal to that state. This specific makes D flip-flops easy to analyze is sequential circuit design. T flip-flop extension table. The T flip-flop toggles its state when t equals to 1 and holds when t equals to 0. The extension table clearly shows the condition for toggling or maintaining the current state. T flip-flops are often used to counters and toggle circuits. SR flip-flop extension tables. There are two truth tables, SR truth table, extension table of SR flip-flop. The SR flip-flop extension table specifies the S and R inputs needed for transitions. It is required careful handling to avoid involved state where S equals to R equals to 1. Proper extension table analyzes input table for or predictable flip-flop behavior. Using extension tables in circuit design, extension tables help determine the minimal input signals required for desired state changes. They are instrumental in designing flip-flop input logic for complex and sequential circuits. Proper use of extension tables results in efficient and reliable circuit operations. Step-by-step design method. identify the current and desired states in the sequential circuit, constantly the appreciate sequential table to find the necessary inputs, implementing the uh, derived input signals to control the flip-flop accordingly. Example, GK flip-flop state transistor to change from state 0 to 1, and JK extension, the table indicates J equals to 1, K equals to do not care. To revert from 1 to 0, J do not care, K equals to 1. These input conditions are used to design the flip-flop input logic for the circuit. For any transition, D must be set equal to the desired next state. For a current state of 0 and next state of 1, D equals to 1. This direct relationship simplifies the logic design process. Practically, applications of the extension tables. Extension tables are used in designing counters, shift registers, or memory units. They facilitate the automation of the state transition in digital systems. Engineers rely on extension tables to optimize circuit performance and minimize complex limits and considerations. Extension tables are specific to flip-flop types and may require convention to different types. They do not account for propagation delays or glitches in real circuits. Proper simulation and testing are necessary. After initial design using extension tables. Final tips for designers: always verify flip-flop types for before consulting extension tables. Use extension tables in conjugation with state diagrams for comprehensive design. Practice analyzing variation flip-flop transition to improve circuit designing skills. Thank you. This is our topic.